Okay, good evening, everybody. Welcome to the first STEM Scholars Lecture of the fall 19 semester. I'm still on tiptoes, hold on. I'm a lot shorter than our speaker. My name is Lisa Hammersley. I'm the Interim Dean of the College of Natural Sciences and Mathematics. And I'm really glad that you're all here. Before introducing our speaker, I'd like to thank Capital Public Radio and the Office of Public Affairs here at Sacramento State for their support of this lecture series. So I'm very excited about this evening's lecture. And to be completely honest, I'm more than a little envious of our speaker, Kathy Kasic, right here. Antarctica is a place I've always wanted to visit. And the further through life I get, the more people I met who've been there, and the more it stings that I haven't been there. So it's stinging a little bit harder today. Kathy Kasic is a documentary filmmaker and an assistant professor here at Sacramento State. Her films bridge the disciplines of art and science, exploring the space between. Kathy began her career as an evolutionary biologist, recording the vocalizations of nocturnal frogs in the Ecuadorian Amazon and Panama. Then, during a field season, she took an infrared camera with her, and that prompted her to follow a path of filmmaking. Since then, and for the last 16 years, Kathy's been a director and cinematographer of documentaries and experimental films. Her films seek to unveil the human relationship with the natural world through a phenomenological emphasis on place. Her work has screened at international festivals, museums, galleries, and been broadcast on television, including BBC, Discovery, PBS, and National Geographic. My top 4. After working independently for 7 years through her company Metamorph Films, she taught for 6 years at Montana State University, where she founded MSU's Center for the Communication of Science, an interdisciplinary initiative dedicated to fusing the arts and sciences. In 2016 to 18, she was the resident director of film arts at Tippett Rise Art Center, a world-renowned venue for large-scale sculpture and music. Luckily for us, Kathy then joined Sacramento State as an assistant professor in the Communication Studies department. Over the course of her career, Kathy's artistic vision and drive for adventure have brought her to film off the bow of a ship, underwater in free-flowing mountain rivers, and recently to an unexplored subglacial lake 3,500 feet beneath the ice in Antarctica. She believes strongly in the idea that art and science are two sides of the same coin, and I agree. They are not mutually exclusive and in fact need each other to move forward in our changing world. So with no further ado, I'd like us to all welcome our speaker, Kathy Kasic.
Thank you, Lisa. Okay. Well, thank you all for joining us today. I'm looking forward to talking a little bit about this project. Can you all hear me okay? Seems like that might be better. I think I might just do this. Okay. So Antarctica is one of the most revered environments on our planet, holding deep cultural and scientific mysteries. Perhaps our reverent curiosity comes from its mere distance from us, lying at over 8,500 miles from here, from Sacramento at least. Or is it that its ferocious cold and howling wind has claimed the lives of some of our most heroic, iconic explorers? Or is it the fact that it's almost completely blanketed in ice? Though not in the least bit soft, the very view of it seems to repel us and invite us in the same instant. Despite its enigmatic seclusion at the bottom of the Earth, Antarctica has its effect on us, not only in cultural mythos, but also due to its effect on climate and ocean systems. Antarctica's ice holds deep secrets to a past long frozen in time, before our recorded history. Its ice is also a large reservoir that, when it melts, will cause the sea level to rise. So what happens in Antarctica has the potential to greatly influence our existence in the years to come. So understanding how the ice has changed in the past is of critical importance for how we anticipate the future effects of climate change on our planet. So one of the best ways to understand this past melting is by looking at what's happening underneath the ice sheet, or what's known as the subglacial environment, because it holds a history there. Furthermore, the discovery of what kind of life might exist beneath that ice sheet has implications that will tell us more about our own existence and how life itself has evolved. But Antarctica's subglacial environment has been so scarcely explored that we know more about the surface of Mars. So it was these ideas that unified a very interdisciplinary group of scientists to embark on a project that, after 3.5 years of careful planning, had us all camping on the ice in tents in December of last year through January for 3 weeks. So this was our tent city. And that's the chief scientist, John Prisky, walking there. Oh, hang on a second. A little issue. So anyway, this is our tent city. And we drilled a small hole about 2 feet in diameter and almost a mile down, actually 3,500 feet underneath the ice sheet, to explore a lake known as Subglacial Lake Mercer. So since I'm a filmmaker, I spent my time taking photos and making films. And so my role on this National Science Foundation grant was as the education and outreach coordinator. I was a principal investigator on the grant. So in researching what I might do for this grant, I came across this silent film by Herbert Ponting called The Great White Silence. It's from 1924, and it's about Robert Scott's expedition to the South Pole in 1910 to 1913. Instead of 3 weeks, they had 3 years. He died soon after returning from the South Pole. You know, if you know the story, he was beaten to the pole by Amundsen, a Norwegian explorer, and died just like 10, 12 miles from his food stash on the ice sheet. So one of the title cards in this silent film says, "The Antarctic continent is an ice-clad wilderness of dazzling whiteness and appalling silence. It's the home of nature in her most savage and merciless moods, and it's there that the hurricane and the blizzard are born." And Robert Scott said about the place, "My God, what an awful place." So maybe it is some of these things, you know, but underneath the ice sheet, something completely different is going on. So this is a view of Antarctica if you're looking at the South Pole, right? And you can see South America on the left, there, and South Africa, the bottom there. And so, first of all, some things I want to tell you is that, well, this is where we were, roughly, around there. And the West Antarctic ice sheet is changing, right? We know this. It's always been changing, it's true. But multiple lines of evidence point to a continual rapid loss of ice in response to changing atmospheric and oceanic conditions. According to the National Snow and Ice Data Center, models of its behavior indicate a potential for catastrophic, accelerated ice loss as climate change continues to push the system towards thinning, faster flow, and retreat. A complete collapse would raise global sea level by 14 feet. So John Mercer, he's the namesake of our lake, Lake Mercer, that we went to. He was a glaciologist. And he was the first to suggest, more than 40 years ago now, that the pressures of climate change could cause the collapse of large parts of the West Antarctic ice sheet. So in his article in Nature in 1978, he predicted that the West Antarctic ice sheet may have collapsed altogether during the last interglacial, when Antarctica was warmer and sea level was higher. He thought that there could be a rapid deglaciation of West Antarctica, leading to a major rise in sea level. So this was his paper in Nature, West Antarctic Ice Sheet and CO2 Greenhouse Effect, a Threat of Disaster. So, of course, at the time, Mercer's views were heavily dismissed, but in recent years, scientists have been watching with increasing concern as that his predictions have started to come true. And you can see this in this graph here, by NASA. West Antarctica is leading the charge in Antarctica for ice melt. Sea level on the whole is predicted to rise, 2 to 3.5 feet. We don't know exactly. Kind of depends on what we do in the future or today. But by 2100, that's what we think, about 2 to 3.5 feet. So I know 2100 sounds a long time away, but we're almost in 2020. But to put it in perspective, the architects who began building Notre Dame Cathedral in 1160 AD took them 100 years to build that. And they didn't stop because they thought that they wouldn't be alive to see it finished. Right? So despite the recent fire, it's still standing 900 years later. So I think we have to think in longer terms beyond our own lifetimes for the future generation. I know that's been said before, but I don't think we can say it enough. Since Mercer's time, we've started to understand some other things that are going on underneath all that ice. So just to refresh your memory, if you're not familiar with subglacial lakes, it's a body of liquid water underneath the ice sheet, just between the ice sheet and the landmass. So the water it remains being liquid because the ice sheet kind of acts as an insulating layer, and also because of all that pressure of the ice sheet actually lowers the freezing point. So in 2007 to 2009, we had a bunch of satellite data from NASA that was interpreted by one of our principal investigators, Helen Fricker, who's at Scripps. She told us that there are over 120-something subglacial lakes across Antarctica. She actually says 124. Well, we've known that there have been subglacial lakes for like over 60 years, but Helen Fricker was able to actually interpret this data that helped us in 2006. I should say in 2007 is when we discovered Lake Mercer, right? So Lake Mercer sits down here, and this is Lake Vostok. It's one of the largest subglacial lakes. Can you believe it? It's one of the largest wetlands in the world. And it's just under ice is all. So there are all these ice streams and things. And Lake Willans is another lake here. So there are only 2 lakes, subglacial lakes, that have ever been accessed. Mercer is the second one, and Willans was in 2012. And Ellsworth was one that we tried to, the British, I say we because I'm actually British by birth. We tried to go here to Ellsworth, but that was not successful. And Vostok, the Russians accessed that, but they did so with drilling fluid. And when you use drilling fluid in a lake, it can contaminate the samples. So they contaminated everything. We used hot water, just like a hot water hose in a hole, like on the ice, and just melted it right through. Okay, so the lake itself probably hadn't seen the light of day for 100,000 years, but as I'm saying, we are still trying to figure all this data out that we've come back with, because it takes some time to go through, so we're still working on whether or not that's exactly the right number. So this is James Sturgill. He's the camp electrician. The whole thing wouldn't have been possible without people like James. We needed power. James provided power. And SALSA is what, you've probably seen that logo, SALSA, Subglacial Antarctic Lakes Scientific Access is what it stands for. Say that a few times. And the carpenters at McMurdo Station, which is the science station, made a bunch of these like wood signs around, and it was really fun. So we had, 20 support staff, 11 PIs, 10 collaborators, 7 grad students, a postdoc, and 7 drillers. And these are the drillers. The entire project would not have happened without this drill team. I mean, of course, there's no science without making a hole in the ice. So they managed to do that, and with difficulty because it's cold there. Okay, so this is the outreach team. You can see me on the left. Billy Collins joined in 2016 and went with me to film in Antarctica, and also went the year before in preparation and also to make another film. And Patrick McGill, he might be here today. He's in the back. He logged all of our footage. Billy and I shot a lot, and he logged it all, and it was really, it's wonderful because we can actually find things now. And then Kathy Trainer was responsible for social media while we were in the field. We'd give her no, I take that back. We would put it on a thumb drive. There was no internet, right? So we put it on a thumb drive, any pictures, video, blogs, anything. give it to a pilot, because a flight would land once a week or so with supplies, if the weather was good. And then, so we give it to the pilot would take it to McMurdo Station, which is the science station, and then our project manager would upload it to Google Drive, and then Kathy would download that and upload it to Instagram. Super fast, huh? So that was Kathy's job, and then we just hired Kevin and Harach. I think they both might be here today too, but just in the process, they're gonna help me continue the work that we've been doing, because people keep graduating on me. Okay, so the outreach could not have happened without the whole team. Actually, this isn't even the whole team, but you know, it's just something I wanted to note. It was a highly collaborative, co-creative environment, and is probably one of the best I've been involved with. So when I was thinking about what I would do for this project, I thought about a filmmaker I admire named Jean Painlevé, who's a French filmmaker, science filmmaker. Started in the 1920s up until the 80s. Used to make a lot of films about seahorses and octopi, maybe some vampire bats, you know, that looked a little bit like Hitler. And it's true. And he thought that maybe we should have 3 versions of every science film, because you can't really reach every audience with just one. And so he thought, well, one could be for scientific meetings, one's for maybe the science audience, like, you know, people who are really interested in science, and then one for the general public, who maybe likes science but isn't crazy about it. And for him, that meant he'd score them to jazz music and have some narration. They're really cool. You should check them out sometime. But anyway, translated to today, that means that we had, of course, the films, but then we developed a logo. We took a transmedia approach, right? Because there are so many platforms, not just audiences. They're on different platforms. So we had a website that we put the logo on. We are working on PBS learning media modules, which are actually for kindergarten through 12th grade educators to be able to download lesson plans so they can just teach whatever science we provide. We're going to do 5 of those. We already have one from the Traverse film that we made. And then we also have just the regular going to schools and talking to kids kind of thing going on. And social media. Let's see, we had a really good run with the news media. The Guardian, BBC, Fox News even covered us, and it was right. and we made some swag because we wanted to feel like a team, and that's what you do in Antarctica, it turns out. They have like patches and stickers, and everybody does this. And because it wasn't my first thought, frankly, but it was cool. It was fun. And then we have this subglacial gallery show. It's an art installation and photo show that we're going to have. So this is what I'm actually going to back out of this PowerPoint and show you a trailer in a second. But I'm making a film called 3,500 Feet Beneath the Ice, and it's a documentary. It's feature length. We also have a couple of short science films. One's called Coring for Climate. The other is Life Below Antarctic Ice. And we're just about finished with the short films, but the feature length one is still going. So I'm just going to show you a trailer from that. And this film actually dives more into kind of the human aspect of the science so that we can tell the climate change science from a human perspective. So hopefully that we can see that kind of science in a new light. Can we get the lights?
Mercer 0332, destination Nibs.
Ready for skis?
Yeah, let's go skis up.
Skis coming up, 3-2 on Victor, how copy?
2, Mercer Camp, reading you loud and clear, how me, over.
Descent will be landing shortly.
Antarctica affects global climate, it affects oceanographic systems, but the most obvious way that affects everyone is through sea level rise. And when you have this much ice, when that ice melts, it will raise sea level. And that will matter to really the entire planet. We've been here for 20 or 21 days.
This is clothes that don't smell so bad, and these are clothes that smell really bad. So that one stays shut. I'll have a sleep mask. This helps because it's daylight all the time.
We're not very far from the South Pole, and we're not very far from where Scott walked along. He walked along those mountains and then took a right turn south over there. Walking in this stuff for 2 months, pulling big sleds by your, human power. Wow. Different kind of people, huh?
Remind you how much of a lunatic Scott and those guys were. Yeah. I was just maybe up onto here, so that then I can just quickly.
I'm an ice driller by trade, one of the few people that make their living by drilling holes in ice in Antarctica for science projects.
So this is how dairy farm stuff. Hey, when you hire farmers to build your drill, that's what you get.
This is a bulk tank from a dairy farm?
This is a new problem. We had a bunch of other problems.
We knew nothing about this continent. Everyone thought it was this big, dead, benign block of ice. But in the last 20 years, and the work done with all these students that are mine and people in my lab, it's all full of life.
Go ahead. Okay, proceed down 1/2 meter, please.
Down to 5%. 1 meter down and 60%.
So when you have a continent that's almost completely covered by ice, and all that ice has the potential to melt and raise sea level, you certainly want to understand its history. And some of those clues are held in the lake sediments.
That's basal ice?
Yeah. So you're looking, remember it's upside down, so you have to stand on your head. That's looking up the hole. But yeah, we're right at the lake interface. Yeah.
That is way different than I pictured it.
So that was the trailer for that film. It should be about 70, I like to say 77 minutes, kind of an arbitrary number, but I like that number. So this is the deep skinny instrument. It's like an ROV, like it fits down a hole. So, a lot of that footage of the basal ice and the lake itself was taken with this. So it had cameras equipped and lasers and instruments for measuring things. And we also had, the GoPro, had to have a GoPro, in a benthic housing. So it's like a deep water rated for 5,000 feet or something. And the film itself also kind of asks the question, what drives us to do this kind of exploratory work? So I actually asked John Priscu, the chief scientist, he's world-renowned polar scientist, really incredible man, but I asked him that question, and this is what he said. Granted, he was tired.
What has driven me to do this? I don't know what drives me to do this. Just my job, right? I mean, that's not what you go to school for. And I don't know. It's kind of like I've been doing polar science so long, I don't know anything else. So it's a long time. So Am I driven to do this? I don't think so. I'm driven.
My favorite quote. Okay, so the science, let's talk a little bit about that. We did 3 different aspects: the hydrology, geology, geomicrobiology. So all these were critical, and I'm going to talk about this science, but also with the help of the other team members through these film clips that we took. So these clips, most of them, some of them are from the longer film, but some of them are from these 2 films that we've just completed, the ones I just told you about. So anyway, with that science, what we had to do was take sediment samples for the geology, and also for the geomicrobiology, which is kind of like understanding how these microbes can live in a cold, dark place. This is a electron microscope image showing a microbial cell attached to a piece of sediment. This isn't actually from Lake Mercer, though. This is from Lake Willans. I can't show you anything yet from Lake Mercer, sorry. So we've got to wait for the papers. So this is this work with the life underneath the ice. It's really important for sort of a testing ground for what if we found life on icy moons? How would we go about doing that? And if you can't do that on Earth, then you're definitely not going to be able to do it there. So some of this research will go towards that idea. Here's one of our clips from a short film called Life Below Antarctic Ice. So I'll just let Brent take it away.
Antarctica in particular is a part of the biosphere that we have ignored. And ignored because we've only recently understood it to be a place that's habitable. The fact that most of the work that we've done on looking for life in Antarctica has focused on things that swim around the margins of the continent and live in places where there isn't ice means that most of the continent is absolutely unexplored. We had very little idea what kind of life forms live there.
People used to think of continental Antarctica as a sort of this big, cold, dead place. And now there's 2 things that we've learned a lot about, is the fact that there's lots and lots of water at the base of the ice sheet, and that also with all of that water, then there's lots and lots of microbial habitat.
Under the Antarctic ice sheet, there are hundreds of subglacial lakes, and very few of those have actually been sampled. So we're going to be going out to a lake called Subglacial Lake Mercer and drilling through the ice into that lake and taking samples for microbiology.
Antarctica is the largest wetland on the planet, and we've studied it in one place. And there are 400 other lakes that exist, and the amount of water that is underneath the ice sheet, it would cover the entire continent with a layer 1 meter thick.
Okay, so you might also be wondering, okay, how did you not contaminate that lake? And so, the image that you saw, the drill hole, there's like a UV collar that radiated everything going down. But I'm going to let some of the other team talk about kind of like how we dealt with the water that we were using to melt the hole.
Our drill puts out what they call 1 megawatt of thermal energy. That's a fair amount. That's about like a bulldozer, the power of a big bulldozer coming through something the size of a pencil.
The borehole water itself is extremely clean. We pass it through a series of filters which remove 99.9% of the cells that are in that water. We pass it through high-intensity UV banks, which then remove another 99.9%. And then finally, that water is heated up to 95 degrees. which is a process we typically refer to as pasteurization. So the water that actually comes out of that hose in there, that borehole, is essentially pharmaceutical grade water.
All right, but how do all those microbes survive under all that ice?
In order to survive in a lake like subglacial Lake Mercer, a microbe would have to be good at extracting nutrients and energy from basically from rocks or from organic material that's been preserved underneath the ice.
There was a time when we thought that life couldn't exist if it was disconnected from the sun. There are many systems in the deep subsurface where we found that chemical energy can fuel them. I think subglacial lakes are also one of those systems. And back to thinking about the possibility for life on other worlds, on a moon or icy body that's quite distant from the sun. These are fundamental questions that we need answers to understand how processes can occur somewhere else in complete darkness.
In this view, there's quite a few cells. Try to bring it into focus. This one is a bacterial cell.
If you are interested in how life started on this planet, you actually have no choice but to be a microbiologist. The ecological and evolutionary history of the Earth is essentially a microbial story. Understanding how life exists somewhere else tells us a lot about how we came to be. We can think about Earth may be a unique place in the universe. That, to me, seems highly unlikely. But if we find other examples of that in our small place in the universe, it means that life may be ubiquitous. So that, to me, is one of the most fascinating things that we can explore in the future. And hopefully I'm alive when we do so.
Okay, more about that in a minute. How about how did we survive out there? Forget the microbes. Okay, so this, that was a windy day when Wei, who you just saw in that video, who was looking for microbes, his tent ripped a couple of times, so we had to replace it. But it was a bad day to replace a tent. So it's okay. We did it, though. It gets much worse, they tell me. That was nothing. I have to go there for an Antarctic winter. So this is our tent setup, and our whole camp, actually. So you can see this is what we call the rack tent. That's where we ate. This is where we slept. This is where we drilled the hole. That was the LARS deck, launch and recovery. These were the labs, sediment lab and the chemistry lab. This is like the drill stuff and the engine room, and this is where I had my camera stuff with the drill team. And this is where you could make a satellite phone call in the tractor. Okay. Oh, and the medical tent. We had a medical tent, that blue thing. I had to go there because I filmed so much, I got carpal tunnel. So that's a bathroom. People always ask me, where's the bathroom? So I had to show that. And then this is one of the grad students. He was hot, I guess. He had to air his socks out. There weren't a lot of showers going on. We did get showers once we got to the lake. We got some water that we could take showers in the drill room. It was actually in the UV filtration room. You had to be careful not to touch anything. There was like 480 volts. It was bad. And this is, we had to build snow walls. You see that behind the tent? You had to build snow walls so the snow doesn't take over your tent. But sometimes the sun, starts to melt those, and that's not so useful anymore. And this is inside the tent. This is inside my tent at night. So it was daylight all the time. hard to sleep that night. And my tent, I had 3 tents. They ripped.
No good.
Okay. Anyway, I had to replace that tent. I think I got the last tent. Oh, and then one morning I woke up and this happened.
Okay, so I'm gonna get out of my tent now. Except my boots are covered in snow. It seems like the snow is slowly taking over my tent. Gonna have to dig a snow wall again, I think. These are my extreme cold weather boots. Whew. Okay. Good morning.
Okay. Kind of everything was a constant effort. Okay, so it was also Christmas time, so we had to, while we were waiting for the drill team to make that hole, we had to entertain ourselves a little bit.
3 more days.
3 more days. That's exciting though, isn't it?
It's like a due date.
Yeah.
Better.
The baby stain.
The baby is brought from the bottom of a lake.
Yeah. Alright, we're just gonna hang them out here until you're ready to.
Yeah, thank you. Yeah, because I think I'll wrap like all the way down with this long piece once I'm done.
And should I just keep doing?
Keep doing what you're doing. You're doing great.
You want me to do the Milky Way ones?
You can
You're
do
just
some
doing
Air
of
New
each?
Zealand ornaments too.
I've been pretty much just doing Snickers.
That's why you've probably never heard subglacial in a song before. This is okay. It just doesn't roll off the musical tongue.
Okay. And also at Christmas time, all the teams, the field camps get together and sing to each other over the radio. And you can come up with your own song if you want to.
Does anybody have anything else? Are you really going to sing this Salsa Navidad?
We're really gonna sing music at noon.
Okay. Oh, he's got the words. It's more than just the first verse.
All right.
Great.
It's gonna be short.
Yeah.
It's gonna be short and sweet.
I said short and to the point.
Oh, well, that works too.
Okay.
Not so tall and straight to the point. Yes, very good.
That's the thing. So that we can hit the and then I'm going to do that same thing where we transition to this. This afternoon twice. Spanish theme. Oh, we did it, baby. Yeah, we did it.
Thank you for that. That was so nice. Any other field camps that want to join in? Boot camp, I know you had some material prepared. Also, I know you have something prepared. Waze has something prepared. Does anyone want to go ahead and take a turn.
Mac Ops. Salsa would love to take the mic.
This is Mac Ops on 7995. Can you repeat that? You are a little bit broken. Over.
Mac Ops, this is Salsa on 7995. We would like to take the mic and sing for you.
Salsa, we read you loud and clear. Go ahead.
You guys ready?
You want to say what we're singing?
Yep. Stand by for transmission of Salsa Navidad by the Salsa Science Team. Here they are.
Salsa Navidad, Salsa Navidad, Salsa Navidad, prospero año de salsa dan. Salsa Navidad, Salsa Navidad, Salsa Navidad, prospero año de salsa dan. We wanna wish you a salsa Christmas. We wanna wish you a salsa Christmas. We wanna wish you a salsa Christmas from the Salvation Mercer Lake. We wanna wish you a salsa Christmas. We wanna wish you a salsa Christmas. We wanna wish you a salsa Christmas from the Salvation Mercer Lake. Yeehaw!
Merry Christmas, everybody! Merry Christmas from Subglacial Lake Mercer.
Thank you, John.
It was a little highlight in my head. I had to film it, so no. I wanted to, though. There were a lot of things I wanted to do that I couldn't do while I was holding that camera. Okay, so this is back to the science again, the premise behind what we wanted to accomplish by getting the sediment from the lake.
And Antarctica holds many secrets because it's the last really big ice-covered part of the world that can contribute to really big meter-level sea level rise. So what we're looking for as geologists is to go back in history and see how often, how much, and perhaps why sea level has changed in the past by looking at the sedimentary record as well as the ice core record.
I think in order to understand where the ice might go in the future, we have to understand when it got here, how it got here, and then periods of ice advance and retreat.
Okay, so more on that again in a second. But just to show you, this is kind of a graphic from the IPCC, International Panel on Climate Change. This is the West Antarctic ice sheet, and what's happening there is that the ocean's warming here and like melting the bottom. And normally what you have in a continental system is that you'd have like bedrock kind of jutting up, but in this area it actually goes down. And so you've got something called the grounding line, and that shifts backwards as the ice melts, right? And so once it goes over this point, you can see that the water will just flow into that, and that's how you get that catastrophic loss. So let me have a salsa scientist explain that differently.
West Antarctica for over 30 years has been anticipated to be the least stable part of the Antarctic ice shelf. And that because the ice is grounded below sea level, that if we warm the oceans around it and the atmosphere on top of it, that we could potentially have catastrophic melting that would then enter the ocean and cause sea level rise. So one of our interests in trying to core deeper into this type of sediment is that as these sediments are deposited in a perfect setting, they would be deposited as if you could imagine a layer cake, one layer built on top of another. And as you move up in those layers, you're getting into younger and younger sediment until you get to the surface, which is more or less present.
Okay, so could show. I think I might skip this because I'm getting a little shy on time. But these were the instruments that we went down. I might just go halfway in. How about that? So that was the multi-core right there.
3 cap cores.
Woo!
Yes. Subsequent to that, we're going to use something that we're calling the borehole jumbo gravity core. And it's going to go down into the borehole. It is about 2,500 pounds all put together. And basically we have to lower the core into the borehole until we get close to the bottom. And then we're going to send something that we call a messenger down. And the messenger just clips onto the rope and we just let it drop. And it goes zooming down the rope and it's going to smash into something at the bottom of the rope and allows the core to free fall so that we can really punch into the sediments.
I mostly just love that animation. Billy Collins did that. And at some point during the coring, we decided it might be good luck just to start dancing.
The shovel, the D1. We're praying.
More dancing, more dance.
Let's get inside.
There you go.
Oh, we just take high. Ooh, Molly. We're getting caught.
All right, so the last film clip I'm going to play you is from the end of the Coring for Climate film. It talks about some tiny algae called diatoms. It kind of will help us to answer some of these questions about when the ocean existed in the past.
One thing that's unique about this environment is that West Antarctica used to have seas across it. At times when the West Antarctic ice sheet was not there, at warmer times, this was a marine basin. And this is where I come in with my science and that of Amy Leventer of looking at one-celled fossil algae called diatoms.
A diatom is a single-celled algae, so it's photosynthetic, and that means that it can only live in the uppermost part of the water column, and so it's telling you things about the upper ocean. So there are two big things that the diatoms can tell us here. One is it can tell us something about the environment, so whether there was different environmental conditions. The other thing they can tell us is they can tell us about the time that it happened. And so one of the big things we want to see here is when were marine waters extending beyond the grounding zone, and this was an open seaway. The other thing that we can see is what's under the Antarctic ice, and that should be eroding out from the bedrock and into our site.
Well, there it is.
You found the Simonsenii?
A piece of a Simonsenii. Actually, I always called it Simonsenii.
I do consider the kind of science I do no different than an historian. And a history professor may look at ancient books, ancient archives, going back page by page, and I do that by going back from the topmost sediment, which was deposited yesterday, and then back through time. Each layer is older in time. I know I described myself as working with the diatoms, that's one language, but there are lots of other languages. And so in some ways we're like this big team that each of us speaks a different language and then we figure out the whole story.
So there is really nice soft mud in there. So I think there's soft mud at the bottom. The problem is the rock.
I feel like my contribution is helping us understand climate, deglaciation, how does the world work, and trying to provide enough information to convince people above me or in a different bracket that this is real. We're just, again, reading the history book and telling them this is how it works. The exploration that we're doing is that because there's a goal beyond ourselves. So we do have adventure when we're out there, but always above that adventure is the mission, which is the science. I think the most impressive things for me is we don't see each of us as individual scientists. We all have one big mission and this idea that the whole is bigger than the sum of the parts.
Ooh. Okay, well, that was the last film clip, but I've got an animation now. And this is the last slide. This image from the Apollo 8 mission to the moon was taken by astronaut Bill Anders on Christmas Eve, 1968, and then turned into an animation by NASA. It's credited as helping to launch the environmental movement, and it is intrinsically a story of human exploration and curiosity. It expresses the wonder Bill Anders felt in looking back at the Earth all by itself. Though we can't all know exactly what he felt that day, the perspective this image gave us of looking at the Earth as a unified whole in a dark universe reframed the planet for our human eyes. The SALSA project is filled with exploratory questions about the past, present, and future. While one aspect of SALSA dives into the wonders of exploration of other life forms alive today, the other aspect reaches backwards to understand the past that might give us clues to our own existence in the future. As we tap into questions of how microbial life might survive in cold, dark environments, we also begin to understand the challenges of climate change and what our own species faces to survive in the future. And what if this research leads to discovering life on icy moons and planets? Would the knowledge of life outside of our planet change how we view life on Earth? Would it change our perspective of our planet the way this image did? Do we have time to find out? Certainly the idea that life can exist in such extremities as a dark, isolated lake instills wonder and awe in the vast capabilities of our planet. And with that awe, is there a way to bring back hope that we can band together on this planet and work together towards solutions for problems that climate change is slated to create, like climate-induced poverty, migration, and conflict? As a species, we must allow ourselves to explore. It's through exploration that we uncover answers about our universe and that we unveil new questions. This inquisitive aspect of our nature is what keeps our society together, wondering about the universe at large, allowing us to band together. But science alone can't help us. In preparing for the effects of climate change, we must focus on developing healthy societies, reviving dialogues of civic living and the awareness of our shared humanity. In facing our unknown future, whether we are scientists, polar scientists, Greta Thunbergs, artists, writers, politicians, or good citizens, we must all do our part, fill our own niches to push our society toward a better future. Thanks for being here. I think there's a little time for questions. Yeah. Oh, we have a mic here. We can't hear you.
Was the setup that we saw in the film just for your project, or is it always there?
It's completely gone now, just for this project. You wouldn't even know we were there.
So how many feet above sea level did you start at? Like the station?
Oh, the station was at sea level, and the lake's actually a little below sea level.
How were those lakes initially found? Is that?
Yeah, first it was through radar in the 1960s, and then NASA has this satellite imagery that's really high quality, and you see sort of like flat spots on the ice, and that tells you that it's probably a lake.
Why did you choose tents?
Why did I choose what?
Choose tents, you know, as their living accommodations.
Tents. Oh yeah, it wasn't my choice. Well, it's hard to get it there, you know. There's nothing there. I mean, yeah, so, I mean, we already had 1 million pounds of equipment that, actually probably more than that, because that was the year before we took 1 million pounds of equipment had left it there over that whole year and then came back with more equipment. So, yeah, I guess like the camp staff, they had nice little little. We should have made it. Well, we made one igloo. That was supposed to be for the science samples, though. I was like, can I sleep in here? No, I couldn't sleep in there.
Hi, Professor. It's Trevor.
Hi, Trevor.
Did you tell them about how you felt about your cell phone after this whole trip? This experience?
Yeah, I wanted to throw it away. My cell phone, how did I feel about it? We didn't have internet or email or anything for quite some time. We did in McMurdo, but it was very slow, painfully slow. And it was actually really nice experience just to be amongst people without this constant distraction that we have. I mean, and you know this is true. We know this is true. But to have that experience again, it was like going back to the 1990s or the 80s or the 70s. I liked that. Yeah. I think, Patrick, yeah.
I was just wondering if there's any like universal feeling amongst the scientists about other outside sources of like outside the science community that actually desire the subglacial lakes and the ice melt to melt away for the resources held under in the open continent.
That's a good question. So luckily for us, the Antarctic Treaty prohibits any kind of resource extraction in Antarctica. And so that treaty was developed in 1959. And yeah, if we suddenly did away with that treaty, we'd have a problem with that. But no, currently there's no possibility for that. And I think it would take more than just Donald Trump to get rid of that. So, yeah.
Were any of those microbes viable at the surface?
No, not that anybody's told me. So, yeah. I think they had been living, though. It's just that by the time they came up. I'm not positive about that, actually. Don't quote me on that. So half of this is still sort of in process, and so we kind of don't want to release too much information, but yeah. They were doing, yeah, I think actually they were viable, I should say that. I'm taking it back. Yeah. Yes? I think we have a question right over here. This man with the black.
I just wanted to ask, how long do you think before they come out with the data?
Well, there are a bunch of papers that are being written right now, so I think we'll probably have about 20 papers that are kind of in process. And I would say in the next 6 months we'll have some.
Have you made a movie that's out there?
Well, these 2 short films are just about done. We're finalizing the text. So I think those will be done in about a week. And then, so those will be out there. And then the long film, probably more like February. Takes a long time. Well, I hope so. We have an agreement with KQED, so hopefully that goes through and that it's picked up nationally. So it's a long process for me as a filmmaker. It's sort of like writing a paper. You submit it, you hope that, yeah.
Hey, Professor, I'm interested in knowing, so your feature, is that what's going to show Mercer Lake in the feature?
Yeah, it'll show all the whole experience.
And
Yeah.
then my second question, who is the audience that the group was singing to?
Oh, that was all of Antarctica. Yeah. Well, anybody who was listening on the radio, let's just say that.
We have time for one more question.
I was wondering, how deep are these subglacial lakes?
So you mean like in terms of the water body or beneath the ice sheet? So this one is 45 feet. Willens was much less than that. I think it was at 20, I want to say 15 feet. We don't know any of the others. I mean, we can kind of gather, we can guess, but we didn't even know how deep this was going to be. And we learned that there was a fill and drain cycle as well. So like, it's constantly filling and draining. It's got a pattern. So we didn't know, we were actually on the drain cycle, just about to be on the drain cycle when we went there. And we knew that, but so we were actually kind of worried that there wouldn't be water, or, you know, I mean, there's all kinds of worries when you're just dealing with satellite data. Yeah.
Thank you all so much for coming. Thank you, Professor Kasic.
Thank you.